Okay, I think we are live now. Can someone confirm if I'm live and audible? Yes, Google says yes. Okay, perfect. Okay, so we are going to be solving Codeforces round 778, Div-1 plus Div-2 today. And we'll be doing A, B, C, and also discussing the solution for D as well. But I was not able to do C. Don't worry, we'll be solving C. I'll be going in order only, so I'll start from A and move till D. And okay, cool. Is the stream buffering? I have a feeling that it is buffering. Can someone confirm? Let me check my speed as well. Oh, okay, cool. Okay, should we start then? I don't see many people in the stream today. Maybe that's because I have been inconsistent, and the other reason is that it is a very unusual timing for the stream. Okay, cool. Let's start. So I'll be starting with problem A, and I think we'll do problem ABC very fast today. So let's start. Okay, so in problem A, it says that there are n pieces of cake on a line. The ith piece of cake has weight AI. The tastiness of the cake is the maximal total weight of two adjacent pieces of cake. Okay, so basically, you need to select any two adjacent values. Let's say if you took A2 and A3, then the maximum taste will be A2 plus A3. Okay, so you need to find the maximum value of any two consecutive values, and that is the taste of that cake. Now, you want to maximize the taste of the cake. You are allowed to do the following operation at most once. Doing more operations would ruin the cake. Okay, now in this operation, choose a contiguous subsegment of A from L to R of pieces of cake LR less than N and reverse it. The subsegment ALR of the array A is the subsequent AL till R. Okay, cool. Okay, for example, okay, let's see. So basically, if we had 5, 2, 1, 4, 7, 3, and we reversed from A2 to A5. So basically, we reversed 2, 1, 4. 2, 1, 4, 7. Okay, so the final array becomes 5, 7, 4, 1, 2, 3. And the tastiness of the cake is now 5 plus 7 because these two adjacent values have the maximum sum. Okay, so let's try this for the very first example. So the first example is the same only. Let's do this for the next example. For the third example, let's say. So we had three values which are 69, 54, and 91. Now, if you don't do any operation, the sum of these two is 69 plus 54 actually makes 113. The sum of these two is 145. And this is larger. But if we reverse these two elements, the new array becomes 69, 91, and 54. And as you can see, the sum of these two values is actually 170. 160, sorry. Yeah, 160. And this is the maximum value. So this reversal was important to gain the maximum value. Now, how to determine which reversals are important? If you see, we can actually sort an array using this reversing technique. Let's say we had 5 elements. We had A1, A2, A3, A4, A5. And we knew that A2 was the highest value. What we would do is, we would actually select this array and reverse it. Now, the new array would become A1, A5, A4, A3, and A2. Now, let's say out of these four values, we knew that A1 was the highest. So, we would actually reverse this array now. And now it would make A3, A4, A5, A1, A2. And as you can see, so on, we can actually sort this complete array. So, all you had to do was sort the complete array, take the last two elements because these two are the highest elements. Okay, I'll also show you my code. Is here. Okay, so this is the code that I wrote. So basically what I did was I just scanned the complete array, sorted them, and took the last two elements and printed the summation of these two elements. And that's it. Okay, I hope everybody is clear with this one. Let's do problem 2 now. Problem B. Again, another simple equation. You're given a string S consisting of lowercase letters of the English alphabet. You must perform the following algorithm on S. Let X be the length of the longest prefix of S, which occurs somewhere else in S as a contiguous substring. The other occurrence may also intersect the prefix. If X equals to 0, break A, B, ABC. Sorry. Otherwise, remove the first 6 characters of S and repeat. So basically, what they're trying to say is that, let's take the example which they have given. They say we have A, B, C, A, B, D, and C. Now, if you consider this substring AB, if you consider this substring AB, you'll actually see that this substring is also present here. And since it is present at another place as well, we can actually remove this part. So the new string now becomes C, A, B, D, C. Now if you see, if you consider this C as a prefix and this C as a substring, you see these two elements, these two substrings are exactly similar. Hence, we can also remove this C as well, and now the string becomes A, B, D, C. Now, if you see, every element in this is different, and hence there is no string which is repeated twice, and hence we cannot do this. Okay, so basically this becomes the solution. Okay, now how to do this? All you had to do was check for the occurrence of every alphabet, because they don't have, we don't really need to minimize the number of operations. So even if you had, let's say, Codeforces, if you had Codeforces, we know that C occurs 2 times in the string, so we can remove this C. Now this O also occurs 2 times in the string, so we can remove this O as well. But if you see, this D occurs only once, and hence we cannot remove this D, hence this becomes the final string. Okay, and that is all you had to do. So basically what I did was I actually used the map to find the occurrence of all the characters, and then just did a normal traversal of the string to see which element was only once. Okay, so basically this is how I wrote it. So basically I made a map, and in this map I did m of si plus plus. So basically for every occurrence of every character, I'm actually incrementing its count. Then I did a normal iteration from I equals to 0 to I less than n, and if any character had a occurrence of greater than 1, I actually removed it occurrence. So basically when we were at Codeforces, Codeforces, we know that C occurred 2 times. So when I came to C, I actually decreased the occurrence to 1. Then came A, which was also 2 times. So I actually decreased its occurrence once, and now again it is once. When I came to D, I saw that the count of this G is 1 only. So I actually stored this index, that index equals to I, and then broke out of this, and then printed this rest of the array. And that is all. And that's all for problem D as well. Problem B as well. Okay. Will you explain D? Yes, I will explain D. Although I don't really have my code to show because I couldn't complete my code, but I know the logic of how it is to be solved. Nadeep, sir, Codeforces rating can only be increased by giving live contest. Yes, it can only be increased by giving live contest. My solution is the exact same. That's really nice, Satish. Okay, cool. Let's move to problem C now. Okay. Let's move to problem C. Alice and the cake. Again, another simple problem. Today's ABC were very easy, I would say. And D was comparatively hard, given that D only had a rating of 1750. I would say. Solved A and B in 20 minutes and stuck on C for the rest of the contest. Okay, Babu, let's see where you were stuck in this one. Okay. Alice has a cake and she's going to cut it. She'll perform the following operation n minus 1 times. Choose a piece of the cake initially. The cake is all one piece. So basically, in the starting, Alice has a complete cake. Let's say the weight of this cake is W. Okay. Now, if the weight is greater than 2, we can actually cut this into 2 smaller pieces, W by 2 and W by 2. Now, since if this is even, then W by 2, W by 2. But if it is odd, we actually need to take the rest one part into something as well. So we'll actually say, let's take the ceiling of this one and floor of this one. What this actually means is that, let's say W was 7. Okay, then we can actually split this into 3 and 4. But if it was 6, we'll only split this into 3 and 3. Okay. Okay, lagging video. Is that so? Is that for everyone or just one person? Video is lagging. Is that okay? I think it is for everyone. Okay, how? Not for me. Hitesh says not for me. Okay. Okay, I don't think I can actually a little bit. Okay, I think that's okay because I don't really know how to solve this problem at the moment. So let's continue with the stream only. Okay, now, so this is what. So basically, 7 by 2 is actually 3. So ceiling remains 3 and floor remains a little bit, but understandable. Okay, cool. Okay, so what is 7 by 2? 7 by 2 is actually 3.5. Now, floor of 3.5 is 3 and ceiling of 3.5 is 4. So this part becomes 4, this part becomes 3. But if W is 6, then W by 2 actually becomes 3 only. Floor and ceiling both remains 3. Okay. So, okay. Now, what they are saying is that after cutting the cake as n pieces, she will line up these n pieces on the table in an arbitrary order. Let ai be the weight of the ith piece on the in the line. Given in the array A, determine whether there exists an initial weight and sequence of operations which results in A. Okay, let's take an example. Let's say we had this example. Okay, so we have seven. Okay, let's take a smaller example first. Let's take which one? Let's take this one. Okay, fourth one. So we have 2, 3 and 1. Now if you see, the sum of these is 6. Therefore we need to start with 6. Since this 6 is not present in this array, let's divide the 6. This 6 actually gets divided into 3 and 3. Okay, now we know that we can actually make this 3 equal to this 3 in this array. We are left with this 2 and this 1. What if we divide this 3 further? We get 2 and 1. This 2 is equals to this one is equals to this one. So if you see, leaf nodes are 3, 2 and 1, and this is the complete array. Therefore the answer for this one is actually going to be yes. Okay, is that fine? Let's consider a little bigger example. Okay, let's say we had 7, 1, 1, 1, 3, 1, 3, 3, 2 and 3. Okay, and let me just remove my screen. Okay, so this is the complete array. What is the sum of this complete array? The sum is 7 plus 3, 10, 13, 14, 20, 25. The complete sum of this array is 25. Okay, now let's start dividing this. If we divide 25, we get what? 12 and 13. Okay, now since 12 and 13, both of these elements are now nowhere to be found in this array, that means we need to divide these two elements further. 12 gets divided into what? 6 plus 6. 13 gets divided into 6 plus 7. Now if you see, this 7 is actually present here. Therefore, we can consider that we got the 7 from here and there's no need of dividing this. Okay, now we are left with 3 values, 6, 6 and 6. Let's start dividing these also. So this 6 gets divided into 3, 3. This divided into 3, 3. And this also into 3 and 3. Now we have 1, 2, 3, 4 threes here. So let's say we took this, this and this for this one, this one, this one and this one. Okay, now we are only left with 4 ones and 1 2, and we have 1 3 and 1 3. Let's divide this even further. We get 2 and 1, and when we divide this 3 also, we get 2 and 1. Now we can actually manage this 2 with this 2, this one with this one, this one with this one, and now since we're only left with this 2, we can actually further divide this into 1 and 1. Okay, we can further divide this into 1 and 1, and these 1 and 1 are actually this one and this one. And now if you see, all these leaf nodes are actually equal to some value in this array, and this array is completely filled with all these leaf nodes. Hence we can actually divide this complete array. Okay, and hence the answer for this test case, okay, the answer for this test case, which is the fourth class test case, was yes. Okay, now should we consider another test case also in which the answer is no? This is pretty much the logic. Okay, how to implement this, that I'll show you. Let's take another example. Okay, let's take which one? Should we take this? Okay, something with a no, which is this one. Okay, let's take the second last example, which is and I'll even show you like how to implement this in this one. Okay, so we had 2, 3, 2, 2, 1 and then 5 times 2. Okay, cool. Let's see. So the summation of this complete array is actually 10 plus 15 plus 5, 20. Okay, now let's divide this 20 into 10 and 10. Okay, or let's do a better example, better way. Okay, instead of having drawing a tree, let's say we had a queue, and this is the queue, and in this queue I actually inserted 20. Okay. Now, since this 20 is not present in this array, I'll actually pop this 20. So pop this 20 and push the two divisions of these, which are 10 and 10. Okay. Now, again, if you pop the lowermost element of this queue, which is 10, you'll see that this is not present in this array anymore. Okay. So you'll actually pop this 10 and push the smaller variants of this one. So this is 5 and this is 5. Again, the topmost element of this queue is actually 10 only. So again, pop this one and push 5 and 5. Okay. Now, if you took the lowermost element of this queue, which is this 5, this will be divided into 3 and 2. Now, again doing the, okay, let me just make a new queue. We had 5, 5, 5, 3, 2. Okay. And let me just remove this. Okay. Now, again, we received a 5. Since 5 is not present in this array, we again popped this and inserted 3 and 2. Again, for this 5 also, we actually pushed 3 and 2. And for this 5 also, we pushed 3 and 2. Okay. So, now if you pop the lowermost element of this queue, which is this 3, you'll see that we have a 3 present in this array. So, remove this 3 from the queue and remove this 3 from the array as well. Now, again, the lowermost element in this array is 2. Okay. And we also have a 2 here. So remove this 2 from here and remove this 2 from here. Now the next value comes is this 3. Since this 3 is not present anywhere in the array, pop this element and insert 1 and 2, which are parts of this array. Okay, so I'll again make this one. So we have 2, 3, 2, 3, sorry, 2, 3, 2, 3, 2, 1 and 2. Okay, so this is the queue at the moment. Okay. Now the lowermost element of this queue is this 2, and this 2 is present in the array, so we remove this 2 and remove this 2 from here. Now the next value is 3, but since 3 is not present, we actually remove this and insert the divisions of those 3, which is 1 and 2. Okay. Now the next value comes as this 2. Since a 2 is present here, we can actually remove this and this. Now again, since this 3 is not present in the array, we again divide this 3 into 1 and 2. Okay. Now the next value comes as 2, which is present in the array. So we remove 1, 2 from this array and 2 from here. Next value is 1. So we take this 1, remove this 1 from here. Next value is 2. We remove this 2, we remove 1, 2 from this array. Next value is 1. But there is no 1 present in the array. And since 1 can one can furthermore not be divided, therefore we cannot do anything and we can just say that there is no answer, because this one will always exist. Okay, and this one is not present in this array, therefore we can straight away say that the answer for this one is no. Okay, and that is pretty much the complete logic. So basically, if you reach a point which is not present in this array, okay, and cannot be divided, then we can say the answer is no. Now Netik says, I got TLA with the recursion tree method. Okay, this is a very good thing, that very good doubt, that why do we get a TLA with this approach? The reason is that, let's say we had a very large value, which was, what do we say, 10 to the power 9. And let's say we had only, this was the sum. If we keep on dividing this, in order to have all the elements in the end, we will actually have 10 to the power 9 times 111. Okay, and if we try to divide this into these many positions, we'll actually get a TL. Now, how to handle for such case? In order to handle for such case, we know that the size of the maximum array is actually 10 to the power 5. It is actually given in the question that the size of the array is actually 2 into 10 to the power 5. Maximum length of the array is 2 into 10 to the power 5. So what you need to do is, if at any point size of this queue becomes greater than all the remaining elements in the array, you can just straight away say no. The reason for this is because we already have more elements in this queue. So whenever we divide any element, the size of this queue will obviously increase. Okay, but this size will obviously decrease whenever we find a value. Therefore, there is no way this queue will ever be equal to this array, and hence we can straight away say no. I think this will become more clear if I show you the code. So let me just show you my code as well. Okay. Now, can you please explain the time complex in detail for C? Yes, I'll explain that after explaining the logic. Okay, we always need to check max value first, so priority queue is best for this one. Not really. Like I actually implemented this using a map and a queue. Okay, so I don't think priority queue is necessary, and I don't think we even need a max value. So okay, let's see how I did it. So basically, what I did was I actually made a multiset with the name ms, and in this multiset, I'm actually storing the complete array which were given in the input. Okay. Then after that, what I'm actually doing is I actually take all the elements which are given, insert them in the multiset, and find the total sum. After finding the total sum, I insert this total sum in the queue. Okay. And while the queue is not empty, okay, so this actually says that while queue is not empty, I take the frontmost element in the queue, which is the lowermost element in the queue, pop that out and store that value in ABC. Now, if this ABC is not present in the multiset, that means I need to divide this value into smaller pieces. Okay. So if it is present in the multiset, I just remove this from the multiset and keep on moving forward. But if it is not present in the multiset, I first check if it is equals to 1, because if it is equals to 1, that means I cannot divide this further, and hence I need to break out of this loop, and I can say that the answer is no. But if it is something greater than 1, then I can actually divide this into smaller pieces. So I did ABC by 2 and ABC by 2 plus ABC percentage 2. This is for the ceiling one. Okay. If you need to find, so basically if it is ABC 7, this will give you 3 and this will give you 4. Now, after pushing these two elements in the queue, if the size of the queue becomes greater than the size of all the remaining elements in the multiset, we can just break out of this loop, because after pushing every element in the queue, the size of the queue actually keeps on increasing. Whereas if you remove elements from the multiset size keeps getting decreased. Therefore, there is no way this queue will actually like come to a size where it is equal to 0. I have a doubt how to decide whether to use a vector or a multiset. The reason why we use multiset is because if you have to like find that element in that multiset, okay. Yeah, Ashish actually pointed it out also to erase the element in log n, both to erase and find the element in the multiset, because it takes log n complexity for a multiset, but whereas for a vector you need O of n complexity. Okay, then in the end I just checked if my flag is equals to 1, I printed no, otherwise I printed yes. I hope this is clear to everyone now. If it is clear to everyone, we can move on to problem D then. Time complexity, okay. How to define the time complexity of this one? Okay. What is the maximum size of, okay, let's see. Let's open the problem again. What is the maximum value of sum here? The maximum value which this sum can get is, okay, so basically AI, the maximum value of AI is 10 to the power 9 and n is 2 into 10 to the power 6. So the maximum value of AI can be 10 to the power what? 40. Okay. So maximum sum will be 10 to the power 40. Okay. Now let's go to the code again. Now I'm actually doing this while queue is not empty. Okay. And I'm actually inserting the sum initially in the queue. Then I'm dividing these two into two equal parts. Okay. So I need to keep on dividing until the size of this queue actually becomes greater than multiset size, or multiset actually becomes equal to 0. Now the highest size of multiset is 2 into 10 to the power 5. So if at any point my size of the size of my queue is greater than 2 into 10 to the power 5, that means that is the worst case complexity. Okay, so basically this is n, nothing but n. Maximum size of multiset will be n. So if I can make the size of my queue greater than n, okay, then I can say that the answer is no or yes. Okay, and this is the worst case. So I need to keep on dividing until the size of queue becomes n. And to do that, the number of operations I need to do is n by 2. Approximately n by 2. Because basically initially my size was 1, then my size becomes 2, then my size becomes 3, then my size becomes 4. Not n by 2, actually n. Okay. So I need to do n operations so that my size becomes n. So basically for every test case, complexity is O of n. And since we are given that the worst like it is guaranteed that the sum of n for all test cases is 2 into 10 to the power 5. Therefore, we can say that the time complexity of this complete approach is 2 into 10 to the power 5. Worst case time complexity. Yeah, and that's it for problem C as well. And I can see many people saying clear, so I think it is clear to everyone now. If yes, we can move forward to problem D then. Akash says got it, thanks. Okay, cool. Okay, also I don't see many people liking the stream. Can you please like the stream so that it reaches to many people? And we can move on to problem D now. For every test case, it is n log n. Yeah, actually n log n, because we are also searching few elements in the array. So we can say O of n log n. Yeah, I missed that log n. Okay, shall we move on to problem D now? D is a really good question, I would say, and something with a very heavy implementation. Even I couldn't do solve D because of the implementation. Okay, all right, let's move on to problem D now. So in problem D, we have Alice's potion making professor gave the following assignment to his students: brew potion using n ingredients such that the proportion of ingredient I in the final potion is Ri. Okay, so basically what you have is a final potion. Let's say the amount of this potion is 1. This is actually made using n ingredients. We have R1, R2, R3. Okay, just a second. So let's say this was the completing portion and it was made using R1, R2, R3 and so on till Rn. And sum of all these is actually equals to 1 because these are ratios actually. Okay, now if order is now all remember the set of n minus 1 parts of the form ingredient I and j should have a ratio of x to y. Basically what it means is that let's say amount of the very first ingredient was x1 or a1, let's say. Amount of the same ingredient was a2 and so on till a of n. What he's trying to say is that a of I upon a of j is actually equals to x by y. This is what he's trying to say. And we are given n minus 1 type of functions. Okay. Now, find total n of ingredient needed to make a potion which passes the class. As a result, can be realized printed modulo this. Okay. So basically, what we are given is, like it says buffering. Is that for everyone? Yeah, I think it's for everyone. Is it buffering a little too much? Yes. Just for complete. I don't see any comments. Okay, anyways, I think I should continue. Okay, cool. Now let's continue. So this is that between ingredient 3 and ingredient 2, there is a ratio of 3 by 4. Between ingredient 1 and 2, there is a ratio of 3 by 4. 3 is for 2 and 4 is for 1. And between ingredient 1 and 4, there is a ratio of 2 by 4. So this is 2 and this is. Okay. Now, what I make arrows here. And start. Now, if this 4, so that let's